Alright, in this lesson we will learn how to prove whether or not two triangles are similar. There are three different ways to prove that two triangles are similar. One is side-side-side similarity. If all three pairs of sides are proportional, that just means they're going to all make the same ratio if I make fractions out of them. For example, 10 over 5, 10 and 5 are corresponding sides, and if I do 10 over 5 as a ratio, I get 2. 6 and 3 are corresponding sides, and if I do 6 over 3, I get 2. 12 and 6 are corresponding sides. If I do 12 over 6, I get 2. So this is what it means when I say the all three pairs of sides need to be proportional. So that would be side-side-side similarity. By the way, these three ratios that all turn out to be the same, this is called the scale factor. So we would say the scale factor is 2. Alright, and in this context that means that the big triangle is twice as big as the small triangle. Anyway, in addition to side-side-side similarity, we can prove that two triangles are similar if they have two angles that are the same. Like 65 and 30, the small triangle has degrees 65 and 30. That's enough to prove that these two triangles are similar. And the third and final way to prove that two triangles are similar is side-angle side similarity. The S and S again refer to the sides being proportional. So I mean, I used the same number, so we've already done the math, but these are still proportional, meaning that the 10 over 5 equals 2 in the same way that if we've got the 12 and the 6, again 12 over 6 equals 2. So we have two pairs of sides that are proportional, and then one angle that is congruent. It's important that the angle that is congruent is between the sides that are proportional. Alright, so for problem number 4, we need to determine, are these two triangles similar? If they're not, we have to say why. If they are, we're going to make a similarity statement. We only have sides given, so we're shooting for side-side-side similarity. Well, let's see. Looking at these sides right here, right? We have the 35 and the 35 and the 10 and the 10. So they're identical, so it doesn't really matter, but for example, I could treat these as corresponding sides, alright, as being the largest. I could treat these as corresponding sides as they're each the smallest. And I could treat this as being the third side. Alright, obviously these two are identical, so it doesn't really matter which one is green and which one is blue. Let's check to see if the sides are proportional. If I do the greens, that is 35 over 10. Okay, both of these are divisible by 5. Alright, 35 divided by 5, that's 7. 10 divided by 5 is 2, so 7 over 2. Alright, if you have any trouble with that, 35 over 10. That is not a 10. Okay, you see it is 7 over 2. Okay, now let's check the pinks. That would be 28 over 8. Okay, 7 over 2 again. And obviously the blues are the same as the greens. So when I do the 35 over 10. Of course, once again, I'm going to get 7 over 2. So because we got the same ratio all 3 times, then these are going to be similar by side-side-side similarity. So we can say that triangle JKL is similar to triangle XYZ by side-side-side similarity. Alright, let's take a look at number 5. Now, we don't have the sides this time, so we're going to have to do something else. What's this? These little arrows here. This is interesting. Do you remember what these mean, these little arrows? They don't mean congruent, they mean parallel. Alright, and we learned that if we have a parallel, if we have parallel lines cut by a transversal, alright, which is what we have going on here. You know, if I were to extend this out a little bit just to make a point. Okay, hopefully you see I've got parallel lines cut by a transversal. This and this, these are corresponding angles, remember? Those are going to be congruent. It's the same thing on this end over here. I've got parallel lines being cut by a transversal. Again, these are corresponding angles. They will also be congruent. So you got to keep all that stuff in your brain. So let me just clean up the picture though. So parallel lines, transversals, corresponding angles. So these angles are going to be congruent and these angles are going to be congruent. Okay, that's a lot of angles. That's already as much as we need. All we need are 2 pairs of congruent angles for angle-angle similarity. But we also know the third, because the third is a shared angle. So that's going to always be congruent. Alright, but I didn't even need the third one. I had it from the first 2. So we can say that the inner triangle will be similar to the outer triangle by angle-angle similarity. So I will say that triangle, let's see, I'll say PWX is similar to triangle ZWY. And we'll have to say that it is by angle-angle similarity. Alright, it's not angle-angle-angle, it's just angle-angle similarity. Okay, that's number 5. How about number 6? Now for this one, we have 2 sides and an angle of one triangle, and then we have 2 sides and the included angle of another triangle. You see right away the angles are congruent. So look, we're shooting for side angle side similarity. Now we have the angle part. Now for similarity, the sides do not need to be congruent, they need to be proportional. So we need to check corresponding sides and see if they're going to be proportional. So that's what we're doing. So looking at corresponding sides. Okay, let's see. I use green for the biggest. So 8 is the biggest over here. Now you might think, oh, 8 and 8, they got to be corresponding. Well, no. 8 is the biggest. Between these two, 10 and 2/3 is the biggest. So these are actually corresponding. 6 is the smallest between these two, and 8 is the smallest between these two. So these are actually corresponding. Mixed number, weirdness. Let's convert this to a an improper fraction or a decimal or something. Okay, this is 10 and 2/3. Okay, this is the same thing as 10 plus 2/3. Okay, that's what 10 and 2/3 means. Okay, that is 32 thirds. Okay, so this is 32 thirds. Okay, so now let's compare corresponding sides and see if we get the same ratio. So first let's do the greens. If I do 8 over 32 thirds, okay, what do I get? Now using my calculator, I can set it up as a big old fraction, right? If I go into fraction mode, and so I got 8 in the top, and in the bottom I have another fraction. So I could actually put a second fraction down here and do 32 thirds like this. Okay, and that'll get it, alright, 3/4. Okay, but there's a couple other ways to do it. You could understand that 8 over 32 thirds is the same thing as 8 divided by 32 thirds. Okay, that might be easier to type in your calculator. 8 divided by 32 thirds. Okay, either way you're going to get 3/4. So keep that in mind. Now let's do the pinks. So for the pinks, I'll have 6 over 8. Alright, divide these both by 2 and you have 3/4. So notice we got the same thing both times, so they are proportional. Both pairs of sides are proportional. Okay, so that means these triangles will be similar by side, angle, side similarity. So let's go ahead and make our statement. Be careful how you do your letters. I'm gonna do ACB just to make it easier to match up. Alright, so I'm gonna say triangle ACB is similar to triangle. Now look, when I did ACB, see how I went from pink to green. So I better do the same thing over here. So I'll do KJL, pink to green. Alright, KJL. See how you got to be careful to match up corresponding parts. And they were similar by side, angle, side similarity. Okay. Alright, how long is this video getting? Those are a few good examples. Let's see. 7, 8, 9. I'm going to go ahead and squeeze these in if I can. I'm going to squeeze in 7, 8, and 9 on this video. Okay. Are these triangles similar? So I'm talking about the small triangle and then the bigger triangle. Now I've got an angle happening. If I have one more angle, then that's enough because all I need is 2. Alright, angle, angle, similarity. I don't see anything else, so any ideas? Oh, the shared angle, okay? This angle P is shared, alright? It's the angle for the smaller triangle, but it's also an angle for the big triangle as well. So obviously angle P is going to be congruent for both triangles. So that gives us 2 angles. So these triangles will be similar by angle, angle similarity. Alright, you've got the Q and the S and the P and the P. So now be careful how you do it. Let's see, I'll do this small triangle first. So if I say triangle SPT, okay, this triangle SPT is similar to triangle. Now I have to be very careful. S, see how it has the single mark, okay? That's Q on the big triangle, so I'll do Q. And then I did P next. Well, that's the shared one, so that's definitely going to be corresponding. Alright, so now I've done Q and P, so that just leaves R. And these were similar by angle similarity. Okay, how about these last two, 8 and 9? Okay, well, I've got options, man. Because I've got all three sides, so I could check for side similarity, and I've got this pair of angles, so I could go for side similarity as well. So let's see. First of all, let me do the colors to decide which sides are actually corresponding. That'll help me. Let's do this. Let's pick the biggest one and make it green. So this is the biggest, so that'll be green. Now the biggest among these three is the 25. So those would be corresponding. Alright, now let's do the smallest and make it pink. Alright, so this is the smallest over here. This is the smallest over here. Alright, let's do the remaining one in blue. So blue and blue. Okay, so you see how this 37-degree angle is between the blue and the green, and this 37-degree angle is between the blue and the green. So we have a shot at side similarity. So let's go ahead and test for that. Alright, because that way we only have to do two colors, two pairs, instead of all three. So it's quicker. So let's check. We know the angles are the same. So let's check the green pair of sides. So that would be 30 over 25. 30 over 25. Okay, I can do this in my head, but I've done that lots of times. So I'm going to show how you could use your calculator. So that's 6/5. Okay, now let's do the blues. Let's do the blues. So that would be 24 over 20. Alright, let's see if that gives us the same thing. Oh look, 6/5 again. So the sides, the corresponding sides are proportional, and of course we had the angle in the middle. So that means that these two triangles are similar by side similarity. I'm sure that we could have done the pinks and done side similarity as well. Maybe we'll just follow through and just check that. So if we did the pinks, that would have been 18 over 15, right? So 18 over 15. And 6/5 once again. But we didn't need it. But so you had your choice of methods this time. So I'm going to go ahead and say triangle RPQ. Triangle RPQ is similar to triangle. Now, notice how I went from green to the 37 to blue. Alright, so I went from green and then blue. So I'm going to do the same thing here. I'm going to go green, blue. So that's why I'm going to go F, D, E, green, blue. Okay, got to make sure that matches up. And the way I did it, alright, because I used the greens and the blues and the angles, I did side similarity. So I will say these are congruent by side similarity. Okay, but you could have done side similarity if you wanted to. Alright, last one for this video, number 9. I don't have any sides anywhere. So we're shooting for angle-angle similarity again. You see the 65 and another 65, so we got that. I see this 50 over here, but over here I only have one angle, so I don't know that that's 50 for sure. So am I stuck? Maybe I can't. Any ideas? Anybody? Oh yeah, vertical angles are always congruent. So I can go ahead and say that these this pair of angles will definitely be congruent. So now with the 65s and the vertical angles, that gives me angle-angle similarity. So that's enough. So these two triangles will be similar. So let's just be careful how we match it up. Alright, I'm going to purposefully letter it using the angles that I have marked first. So I'm going to say triangle, and I'm going to go M, J, N. Okay, M, J, N is similar to triangle. Now the M, see the single mark, the 65? That's the same as the L. So I'll put the L next. And then of course the J is the same for both triangles. So I'll go ahead and put the J. So looking at this triangle, I've already done the L and I've done the J, so that just leaves K. Okay, and these were similar by angle-angle similarity. Okay, that is enough for this video. It's a little bit long, so we're going to call it a day. Let's see, but there is more to this lesson, which will continue on another video. So let's see what's coming. Alright, in the next video we will use these diagrams to make similarity statements and complete statements of proportionality. I'll see you on that video in a minute.